Okay, this is Algebra 2, Chapter 2, Section 6, Families of Functions. So families of functions are just various manipulations that you can do to a parent function. A parent function is the simplest form in a set of a functions for a function family. So it's uh, the basic function, like a straight line, like through the origin, would be considered the parent function. It's the simplest form. And then we're going to do stuff to transform it. A transformation of the parent function creates the family of functions, and we're going to talk about various translations. There's two types of translations. We have a horizontal translation and a vertical translation. So if we have a function f of x, that would be our parent function. And this is talking about vertical translations. And translations just means a change. This would be our parent function, f of x, our simplest form of whatever function it is. When we talk about a vertical translation, it can be twofold. It could be f of x plus or minus k. Okay. When it's f of x plus k, it moves the function up. The function goes up along the y-axis. When we talk about f minus k, f of x minus k, the function goes down the y-axis. So the slide that the book gives, we have our parent function in red, which is this guy right here, and we have f plus k, and since it's plus k, and notice that the plus k is going to be on the outside of the parentheses of the x, it's going to slide you up in blue. And then if you have x minus k, it's going to slide you down. It's going to slide you by the distance of k, whatever that is. When we talk about a horizontal translation, our parent function again is f of x. And when we do a horizontal translation, this would be a move to the right along the x-axis. So function moves to the right. On the x-axis. So it's a horizontal shift. And then we have f of x plus k. And that's a function that moves to the left along the x-axis. Yeah. We'll be talking about a horizontal translation, a horizontal slide. So here in red again is the original, and then sliding to the right along the x-axis is the green, f of x minus h inside the parentheses. And f of x plus h inside the parentheses slides it to the left. Okay, and then they have some examples of that. So hey, it says how are functions 2 of x and 2 of x minus 3 related? And how are their graphs related? Well, for 1a, this is a vertical translation and it's going to go down. Right, the initial parent graph is y equals 2x. The translated graph is y equals 2x minus 3, and it's going to go down 3 units vertically. B asked me to graph y equals 3x. I'll try my best to do all this graphing in this limited simulation. 1, 2, 3, 4, 5 to the 0, 0, 1, 3. So it's going to look like that. Oh my god. 1, 2. 1, 3. And if we label our graph, this is y equals 3x. If it's translated up 2 units, the other graph is going to be moved up. So it would be 0, 2, and then 1, 5. And it would look like that. They would be parallel lines, they wouldn't be touching. And that would be y equals 3x plus 2 if it was translated up. I'm just adding 2 to every single y component. Horizontal translation. We have a scenario where I guess the plane leaves 2 hours late, so it has the function of f of x minus 2, which was 2 hours late. 2 hours late, yeah. And then they ask you, well, what if it's half an hour late? Well, or 30 minutes late. So 30 minutes is half of an hour, so it would be x minus 1/2, which would be 30 minutes late. It's a silly question. What function represents the transformation? It's a horizontal shift, and it's going to be a horizontal shift to the right by 1/2. A reflection. When we talk about a reflection, flips the graph across either the y-axis or the x-axis. A reflection flips the graph across either the y-axis or x-axis. When we're talking about flipping across the y-axis, so reflection across the y-axis will be in the form of f of negative x. So what that means is that every x term is going to be negative. When we have a reflection across the, oh my god, I have a reflection. I did, oh my god. That's funny. We talk about a reflection across the x-axis. We're talking about negative f of x. I would even put a bracket around it to sort of simulate that I'm multiplying it by -1. That's sort of how I see it. So across the y-axis, your x-coordinate is going to be negative. It's going to be across the x-axis, basically your y-coordinate is going to be negative. So an example of that, we have h of x which is going to be a reflection of f of x. So we have f of x that equals 3x plus 3. H of x is going to be the reflection of that, and it wants to be it wants the reflection of the x-axis. So g of x equals the reflection across the x-axis, so it will be the negation of the whole entire function f of x. Right? But we know what f of x equals. F of x equals 3x plus 3, so I can substitute that. So it's going to be negative 3x plus 3. It's going to be the negation of that. So I'm going to use the distributive property and say negative 3x minus 3. So g of x equals negative 3x minus 3. That is our equation. So f of x is 3x plus 3, and g of x is negative 3x minus 3. Now, in terms of graphing these things, I have to get a program. So f of x would be 3x plus 3. It would be a across the x-axis, but would be inverted. So, well, I'm not gonna graph it. But that would be the equation. So the best thing to do in these situations is sort of to graph these things is to do the XY chart. I could do it rough shot, but I think it would be better if you do. I always go from -2 to +2, so -6 plus 3, -3, -3 plus 3, 0 plus 3, 3 plus 3, 6 plus 3. So this would be 6 minus 3. Would be 3 minus 3. 0 minus 3. -3 minus 3. -6 minus 6. Notice that the y's switch signs. And that's essentially what's going on. And that flips it across the y-axis. So when I graph these, you would see it flip along the x-axis. No, I'm not going to graph it right now. Vertical and horizontal stretch. When we talk about a vertical stretch, you're multiplying the function. And you're multiplying the function by a number that is greater than 1. So if a is greater than 1, then your function would be, if my parent function is f of x, the transformation or the change would be a times f of x. I'll just put it in brackets, f of x. And that stretches it along the x-axis, and it increases, it gets wider. We have a vertical compression. When we have a vertical compression, our a is going to be between 0 and 1. So it's going to be a decimal or a fraction. We can think of it as 1 over a for a fraction. So if our parent function is f of x, then our vertical compression would be 1 over a. It would be a fraction. f of x. Okay, so that's vertical compression, meaning it pushes it on it so that it shrinks. And this is vertical stretch. Okay. Here's an example of it. Here we have our regular function in blue. Then if you multiply by a in red, you stretch it out, so it stretches out both in the x and the y direction. If you use the fraction 1 over a, then you shrink it and it compresses. Alright, what are the corresponding table graph for the translation of 1 over 3? So, they give us this function. What's the parent? And they give us a scenario here. If you look at this chart, all my x values are here. These are the y values. So the stretch was multiplying by 3. So all your y values are going to be multiplied by 3. So 3 times 2, 3 times 2, 3 times negative 3. And that gives you your compression. You multiply it. So what if you were to find out what, let's call h of x. H of x. H of x would be 1 over a, right? So 1/3 times f of x. So if I do the chart just like so, I'm going to get rid of the 3f of x and I'm going to put in the other. So we have our x, we have our f of x, we have our 1 over 3 f of x, then we're going to have our h of x. And -5, -2, 0, 3, 5, 2, 2, -3, 1, -2. So this would be 1/3 times 2, 1/3 times 2, 1/3 times -3, 1/3 times 1, and 1/3 times -2. So then my h of x would be 2/3, 2/3, -1, 1/3, -2/3. Alright, and that is that section. Just to reflect, vertical translations, you add x or k outside of the parentheses of f of x, and that goes up and down the y-axis. Positive k goes up, negative k goes down. Horizontal translations, you subtract h from inside of the parentheses. Minus h is to go to the right. Plus h is to go to the left. Reflection, You multiply outside the f of x parentheses to go along the reflection along the x-axis. You multiply uh, inside the parentheses x by -1 to reflect across the y-axis. To stretch, you multiply your function by a number greater than 1. To compress, you multiply your function by a number between 1 and 0, fractional or decimal. Right. That is our section. You can combine them, and you can do various things with that, and that's fine. Not going to get into that. You have a great rest of your day.